In my vector tutorial, in this stage we are solving from exercise 13.3. It's a Cambridge Admit book. Question number 1 I am trying to show you. Information written here: OA equals to A, OB equals to B, and diagram also given on the right side. So let me put the values are there. OA equals to A, OB equals to B. R is the midpoint of OA, so we can write this OR, and RA is equal on the right side. And another information, OP equals to 3OB written there. So if we put the vector according to their line, so OB we can put here B, and it is written here OP equals to 3OB. OB means 3OB. OB means 3B we can write. So OB equals to B. So the remaining part BP we can write as a 2B. It's helpful to do our diagram, definitely, to our solve the question. And OA equals to A given, so and R is the midpoint, so you can write half of the part of OA as a by 2 and half of the part of RA as a by 2. That's the total information provided as a vector. And another thing written there, AQ equals to lambda AB, lambda constant they used here, and RQ equals to mu RP. That is the total information provided. So the first question is asking OQ in terms of lambda A and B. So we needed to use the first information, AQ equals to lambda AB. Let me write that. First question, A equals to A OQ equals to, we can go through from O to A, we can go directly, and then from A Q we can write if we want to use the lambda from here. So OA given, OA total is A, let me write, and AQ is here lambda AB. Easily can write here A plus lambda AB, we know OB minus OA. We can break down like this and put our values accordingly. A plus lambda, OB is B and OA is A. So if we write according to the vector, let us take a common from there, then it is 1 minus lambda, then another part is lambda B or B lambda. So this is our first part answer from here in terms of lambda. Then the second one is written here, find OQ in terms of mu AB, another part. So here is the second question is also asking to the OQ but in terms of mu AB. Let us do that. On B we can write OQ equals to, we needed to use the information RQ equals to mu RP. So OR plus RQ we can write OR plus RQ, easily you can write from there. And let me see what is the OR written here. OR part from here to there we already wrote here A by 2, and RQ part is given there mu RP, mu RP. It is provided in our book. So break down mu by 2 plus mu RP. What is the RP? RP. So easily we can write inside OP minus OR. According to the position vector, you can write any vector like this way, OP minus OR. If you don't know this one, so you may see my previous tutorial from the vector. I have done 13.1 and 13.2, all the questions in my previous tutorial, so you may see from there my working. A by 2 plus mu into, let me put OP equals to, OP equals to 3B minus, and OR equals to again A by 2. Let me write A by 2. Yeah. So it's rule actually writing the vector according to their vector. So if we take A by 2 common from there, then inside you can write 1 minus mu, and another part is 3 mu B. This is the second portion of this question, and in terms of mu AB, that is our answer of this question. We have done the B part. Now let's move to the part C. It is written there, find the lambda and the value of mu. Both are constant here. I'm going to use different color to do that question. Here it's very easy because we have two different OQ. One OQ is here, another OQ is there. So just equate both of them. If we equate to, I'm doing this so in the actually bottom part, both OQ, if we write one OQ in terms of lambda, another OQ in terms of mu. So equate both of OQ, a 1 minus lambda plus lambda b, one equation. Another one is a by 2 1 minus mu plus 3 mu b. So let's equate the coefficient of a and coefficient of b. If we equate the coefficient of a, equate the coefficient of a, equating the coefficient of a, because it's a vector equation, we can equate individually. The coefficients are there. Coefficient of a on the left side, it is written 1 minus lambda, and coefficient of a on the right side, it is written half of 1 minus mu. This is our first equation. And if we equate the coefficient of b from the both side, then we would get from there lambda equals to coefficient of b, which you can write 3 mu. This is our second equation. Now we are going to solve that two equation. That's it. Then we would get the answer from our question. Let us solve from the second equation, lambda equals to 3 mu. We can put in the first equation. Then it should be 1 minus 3 mu equals to half of 1 minus mu. Now just cross multiplying, which is, we can write 2 minus 3 to the 6 mu equals to 1 minus mu. From there we can write 2 minus 1 equals to 6 mu minus mu. Then it gives us 5 mu equals to 1, and from there we can write, finally we got mu equals to 1 by 5. This is our mu value. We are going to put this mu in the second equation, which is 3 into 1 by 5, and it gives us 3 by 5. This is our lambda value, and both are constant. This is how we have to do all the maximum questions from here. Question 13.3. Hope guys you enjoyed the way I did the question, and continuously we're doing the rest of the questions from here in my next tutorial. So stay tuned in my channel. Thanks for watching.